VMUG UserCon, where cutting-edge technology meets real-world expertise and where the VMUG community stands at the forefront of the IT industry. At VMUG, we believe in creating experiences that help build community. This is your space to connect, learn, and grow with peers who share your passions and are pushing to the next level. From deep dive technical sessions to hands-on labs and real-world use cases, VMUG programming is designed to keep you ahead of the curve. In-person events, including UserCons, VMUG Connect, executive experiences, and local meetings help bring you directly to your community, empowering you to make real-world connections that have long-standing impacts. Stay connected with international and virtual experiences that make sure you never feel out of the loop. Annual virtual events, webcasts, VMUG town halls, and on-demand content sessions ensure you have answers at your fingertips, no matter where you are. And for those ready to take their VMUG experience to the next level, there's VMUG Advantage, packed with benefits, including exclusive event access, VIP meet and greets, custom behind-the-scenes content, VCP certification discounts, and so much more. VMUG Advantage takes you and your career to the next level. And throughout the year, our valued partners and sponsors bring cutting-edge solutions and insights that help power your IT strategy. Today, you'll hear from industry leaders, VMware experts, dynamic partners who offer compelling new solutions, and visionary thinkers ready to help you take on the next level, backed by the VMware community. Let's get started. Your UserCon begins in just a moment. Grab your seats and get ready for a jam-packed day with VMware.
We're done with the countdown. How's everybody doing in Philadelphia, the home of the Super Bowl champions? Get that for this table over here. I tell you, it was fun watching that video because there's a lot of people that are in this room that were in that video, like Steve, that was voiceover from Matt. It's fantastic. So my name is Brad Tompkins. I'm the VMUG Executive Director, and thank you for being here today. We've got a lot of good information. And if we can switch over my slides here, that would be great. So we've already welcomed you, so we are moving along. But first, what I want to do is have the leaders stand up. So Ed, Adrian, Joe, y'all stand up for me. You're going to be hearing from them later on in the afternoon. Where's Ed? Oh, there he is. He's walking in. Perfect timing. Got to get that coffee. Folks, these gentlemen keep the community alive all throughout the year. Big round of applause. I like that. I like that. Some Philly energy. So they do a tremendous amount, not just on UserCon Day, but all throughout the year. So there's local meetings. You're going to hear about some of those coming up in the afternoon. And they really are keeping the community together. Because let's face it, there's a lot going on in IT. There's this thing called VMware by Broadcom. We're all trying to figure out what that means. And, you know, we're getting through it. But it's great to have a community that you can lean on. And that is what these gentlemen do. So if you're interested in being a volunteer, scan that QR code. You could be a partner, you could be an end user, you could even be a Broadcom employee. But they're always looking for new folks to help volunteer. And it can be at varied levels. So just by clicking the link and doing the QR code doesn't mean you're in. You still have the opportunity to back out. But I would encourage you to do that because it does advance your career. Because as your company is adopting the cloud operating model, you're going to need more than just tech skills. You're going to have to talk to your storage people, your networking people, your C-level people, and all that kind of stuff. And doing leadership and advancing your soft skills is going to help if you do that. So gentlemen, thanks for all you do. How many people here is their first VMUG ever? Never been to a chapter meeting, never been to anything? All right, that's great. So VMUG's mission is for our members to get the most out of VMware and partner solutions. We are not Broadcom. We're actually a 501c. We're a nonprofit organization. But obviously, we are tight with Broadcom. And we have got members all over the globe, and it's a fantastic community. We have local chapters. Of course, the Philly chapter is very active. I see people here from the New Jersey chapter, the New York chapter, the Pittsburgh chapter. So we've got chapters all over the place. So make sure you get plugged in on that. And check out our other events that are in person, they're virtual. You heard Matt talk about that on the pre-video there. So that's what VMUG's mission is for. So speaking of events, we've got some events coming up. The big one is VMUG Connect. This is our first time we're doing a multi-day event. And that's going to be in St. Louis, Missouri. It's an easy 13-hour drive, so I expect all of y'all to be there, or maybe catch a flight, either way. We've got a global event coming up on May 20th as well. So this is a virtual event. This is going to be on Zoom events. They're a platform. We're trying a new platform if you've done some of ours in the past, because we all love Zoom. But anyway, what's interesting about this, and I got to be careful what I say here, this event was May 13th. And we had some people at Broadcom ask us, hey, can you push it a week? So we pushed it to May 20th. So in a completely unrelated story, VCF 9 is supposed to be coming out soon. So you can read between the lines on that one, but go ahead, register for that. It's not quite up yet, but it'll be out soon. So there should be some exciting announcements in that global virtual event. So more on Connect. This is a paid event. If you're an Advantage subscriber, who's an Advantage subscriber? All right, good many of y'all. You can get it for $375. That saves you $175. So again, this is a paid event. It's a two and a half day event. And people ask me, well, Brad, why would I go to Connect when I could just come to a UserCon that's complimentary? So here's the answer. Number one, that gentleman right there, Chris McCain, is going to be there. Yes, you get to see him here. So that might not be the best example because he's showing up here. We also have Frank Denneman, who is from the Netherlands. He is flying in for this. Frank has written multiple books. He's got multiple patents. We also have Hock Tan. Hock Tan is going to be there. We've got a lot of sponsors there, and it's a great time to network in the hallway track. If you go to Explore, he's been to Explore, a lot of hand raising today. He's been to Explore or VMware, whatever we call it now. A lot of people told us, man, we missed the hallway track. That's what we need from a UserCon. So having it multi-day allows us to do those kind of things where you can meet up with people, maybe at a beverage place at night or a coffee shop in the morning, whichever you like there. So check out Connect, and we hope to see you there. All right. These things don't happen without our sponsors, and of course our program sponsor is VMware by Broadcom. There's a lot of Broadcom employees here. We know you have questions, so you can ask them about anything, and they might not have the answer, but they will find the answer. So that's our program sponsor. Our Platinum Preferred is Valley Cyber. Now, Austin is going to be doing the keynote at lunch, and you're going to want to hear that keynote because it is fantastic. He is the CTO of Valley Cyber, and it is a great, highly rated session that we have. So more on that coming up. Our Gold Preferred sponsors are Intel and Pure Storage. I know there's a lot of purists out there, and everybody's running Intel, right? And Xerox as well. If you need some monitoring solutions, you can check them out. So they are all outside to the right. You probably saw them right there when you were getting your food and your coffee and those kind of things. Passport to prizes. You need to have one of these. Go visit all the sponsors, get the stamp, and drop it off, and you have a chance to win some of these prizes. So that is the MetaQuest with the Batman game, and then the Lego set. So lots of good prizes there, and some of these sponsors have swag on their table too, so you can check them out as well. All right, now we're on to our keynote speaker. And Chris has been part of the IT industry for over 20 years. He is an author, and he is a thought leader, and he is responsible to be a global advocate for Broadcom's vision. He's focusing in on network and security, and I've heard this keynote before, and I always learn something new when I hear it, so I'm excited to hear it again. He's also a double BCDX, so he knows his stuff. If you want to try to stump him, you can feel free. Good luck with that, because I've never seen it happen before. And probably the biggest thing is he has Florida winning the bracket. I mean, come on, Florida basketball, they don't have a chance. They got exposed with UConn. But nonetheless, ladies and gentlemen, please welcome to the stage our morning keynote speaker, Mr. Chris McCain.
If I'm not mistaken, you actually had Florida winning too, don't you? All right, so good morning, Philly. I think it's been a few years since I've been here, so good to be back. As Brad mentioned, my name is Chris McCain. I work in the Application Networking and Security Division at VMware by Broadcom. So my focus is primarily on our security technologies right now, although my experience with the VMware product goes way, way back to ESX2. Anybody else in the room? ESX2? Ooh, this is the most number of people I've had raise their hand with ESX2. How many of you started with Virtual Infrastructure 3, VI3? A few more hands. Anybody that started with VI3 by my book that I wrote? Great. Now you guys see why I'm still working. Never really came close to being a New York Times bestseller on virtualization. So let me get set up here. I am not doing any PowerPoint slides this morning. We are going to have, we're going to do some whiteboarding together and talk about how to implement security easily and quickly into your private cloud. So let me do a little share here and we'll get going. There we go. Okay, so first and foremost, I don't like to stay on stage, so this is, those of you that have never been to a VMUG, it's okay. Those of you who are here again, this is the first time I'm ever delivering it while being mobile like this, so pretty unique. And because I have no slides, this presentation can go in any direction that you wanted to if you guys are asking questions. But let's just start out talking generically about security. So one of the most common conversations I have with customers is security versus management. In other words, a lot of customers think that security is complex, that it has to be this difficult thing that we put into our environment, but it's a necessary evil because we know that the landscape of malicious threat actors is constantly growing. But when you look at these two, security versus management, obviously there's an inverse relationship here. The more secure that you want to make something, the harder it becomes to manage. So whenever we design infrastructure and we design for manageability, what we want to do is we want to improve manageability by making things easier to manage. But nothing ever in the history of IT that has to be secured will ever, ever, ever be easier to manage than not having to secure it. It's just the nature of the game. So you're not going to be able to achieve both of these at the same time. And by both of these, I mean simplifying management while also improving security posture. Now, that's not that we can't pick the right tools to improve security, but not go all the way down the path of making it extremely complex to manage. That's the key. How do we get the best return on our investment? How do we buy down risk without introducing a tremendous impact to the operational model of the business? Because the reality is we all work in an industry where we have a lot of things to do already. We're probably already stretched thin. So how do we now add this idea of security to our workload when we already have plenty of things to do? But truth be told, any organization that wants to truly protect themselves against malicious threat actors, security is not something that lives in one isolated silo within the organization. Security has to be part of everybody's job. So if we look at traditional infrastructure, we take our hypervisor, right? So we have ESXi. Underneath that, we have our physical network, we've got some storage, and then of course, there's probably a firewall sitting here, and then we have all of our workloads, our virtual machines, etc., that sit on top of the hypervisor. When it comes to securing the infrastructure, I think we all realize that having just a physical firewall is no longer enough to protect the organization. Threats have evolved in such a way that once a threat actor gets in, it's moving laterally that is the biggest issue. Their ability to move from one system to the next. And that's not something the physical firewall, that north-south firewall, is meant to protect. It's meant to be a boundary between the inside and the outside. So what are our options then? If we are concerned with lateral movement, if we want to prevent an attacker from being able to jump from one system to the next, what are the options? Well, there's three options. So one would be the idea of taking this physical firewall and putting a bunch more of them out here in the network. Now, anybody here a network administrator? Do you like the idea of doing this? No way. Because when you think about it, what we're trying to do is take this concept of a firewall and insert it in between the flows of traffic on a network that we've already designed to pass packets. At which point we now have to redesign. How do we force traffic over these layer 3 boundaries in order to get some level of inspection to determine whether or not we should allow this traffic? It's a very complicated thing to do. So let's not do it that way. The other option is to put an agent inside of every system. And if CrowdStrike didn't teach us about the downside of agents, let me tell you about a few others. One, let's say that there's an issue. You put this agent in, it's securing the application, and something happens now. Application's not functioning properly. What is probably the #1 step in troubleshooting then? Turn off the agent. At which point you just lost security. You no longer have that. The other issue is what happens if the agent-based security is allowing a particular important protocol that a malicious threat actor uses to get into that system and then turn off the agent anyway. You just lost your security. And no matter how short a time, it doesn't matter. As long as they can get in, turn off that security, there's something that they can do. So let's not use an agent. Well, if it's not something that happens at the physical network, and it's not something that happens inside the virtual machine, well, the only thing left is what's in between, and that's your hypervisor. And so that's exactly what Broadcom has done with our vDefend product. So you might have heard the term NSX before. Well, let me explain what's happened since the acquisition of VMware by Broadcom. NSX used to be a product that did both networking and or security. Okay? They've always been mutually exclusive from one another. You did not have to do networking in order to do security, even though there was a rumor or a myth that that was the case. Nowadays, post-acquisition, the networking constructs from NSX are built into the core private cloud platform of VCF. You get a hypervisor, you get networking, you get storage, you get automation, you get operations. All of that is bundled into the private cloud of VMware Cloud Foundation. Security is now called vDefend. And we have vDefend Firewall, which I'm going to be talking about today. And we have vDefend Advanced Threat Prevention, which kicks it up a notch from a security perspective, and I'll mention a little bit about that today. Okay? So if it wasn't clear previously that networking and security were in fact mutually exclusive, it should be very clear now. Because you do not have to do the overlay networking in order to achieve security. And that's one of the things that is resonating most with customers today. Because as you adopt private cloud, you are not going to buy VCF on Friday and have a private cloud on Monday. Customers are trying to figure out, where do I realize value out of this new private cloud that I am supposed to build? Well, oftentimes it doesn't come, the immediate value doesn't come from networking because you already have an existing physical fabric. And like I said, we're already busy. We're not going to introduce a new project to build overlays just because we can. If there's no business case, it's not going to happen. Same thing with storage. You probably have traditional storage. Well, now you're getting vSAN. And so you go, okay, well, I'll use vSAN, I'll add some VMs, but you're not going to introduce a project that does a mass migration of your VMs into vSAN unless you're deprecating your storage, because there's a business case. You're not going to introduce it just because you can. So where's the value? The value is in security. Because you can take all of the things that I'm going to show you today, and you can do these on day one. There's no preparation, there's no change to the network, there's no change to anything you're doing, but you will be able to buy down risk as quickly as I'm going to show you in this presentation. So the architecture then for our security is to place a firewall at the VNIC of every workload running in the hypervisor. Now this isn't fancy, special, magic, sauce, anything like that. We took the concept of a firewall and we abstracted it into the hypervisor to be able to inspect traffic upon ingress and egress. That's it. Now, if you think about it, this really isn't earth-shattering news, because without the firewall, we were already passing your traffic, weren't we? You build a VDS, you give it a VLAN, you trunk it, right, down to the physical switch, and we're passing your traffic. So we said, well, instead of just passing your traffic, what if we add the ability to inspect traffic so that you could actually control whether or not you wanted that traffic to leave the host? What we did here from an architectural standpoint is incredible because we're bringing security as close to the workload as possible without being inside the workload, without it being an agent inside the workload. So we get the best of both worlds here because we are not introducing anything new into the physical fabric. We are not installing any type of agent inside the workload, yet we are still being able to provide this inspection to determine if traffic should continue or not. So architecturally, this is and always will be our competitive advantage because we own the hypervisor. And what this means is that for every Intel box you buy, you are not just getting more CPU and more memory, you are also now getting more firewall capacity. You are getting more IDS/IPS capacity, network detection and response, malware detection, analytics. All of these things are built into the hypervisor as part of the vDefend security solution. So it scales linearly with your data center, no matter what your unit of growth may be. I've worked with customers that say, look, every time we have to grow, we're building an entirely new rack. And I've met with customers saying, if I have to grow, it's just one more server. It doesn't really matter. However you grow the data center, you are now adding more security capability or capacity as you add more and more hosts to the environment. So very easy to scale. Question. I love it. Early question. So the question was, at the end of the day, I end up with numerous firewalls. What about management? Great question. So you're looking at this architecturally, seeing a firewall in front of every one of these VMs, right? Thinking they're individual firewalls. The reality is, it's a filter we put in front with each of these rules, but I'm going to show you how easy it is to build these rules. So when I said what we're doing is not magic sauce, it's not. But the management that we wrap around this is the beautiful part. Because if you look at this thinking, oh, I've got all these individual firewall rules, and you apply traditional firewall thinking to the architecture I just provided, it sucks. If you're thinking, wait a minute, I'm going to go build an IP-based rule that says this IP can or cannot talk to that IP, and I got to micromanage every single VM talking to every other VM, that would be terrible. And I probably would not stand up here and tell you any of this. But the reality is, because we are so deeply embedded into the hypervisor, I'm going to show you ways to build rules that make management extremely easy. And that's the value in this. The management is a single management plane that will distribute the rules efficiently and effectively to every hypervisor where the workloads are relevant to those rules. Okay? That's what we're really changing the game with, is the manageability of this security. Okay, so let's switch gears a little bit. We implement security, yeah. Oh, another great question. Is there resource overhead? So look, remember I had security and manageability up there? I could do that again and I could put security and performance. And the reality is, nothing that's more secure will ever perform better than not having to secure it. So the question becomes, how do we balance this? Because I don't want noticeable impact to my infrastructure at the expense of security. I can't have the application owner saying, hey, we're dropping. It's not working because you implemented this. So this goes back to the architecture. Because we are scaling this horizontally across your data center, we are spreading that across n number of hosts. Okay? Now, that being said, I would expect anywhere from 2 to 3% increase in CPU and memory utilization on the host, which should be negligible, right? Because if you're sitting at 30, 40, 50, 60%, 2 to 3, not a big deal. If you're already at 95% utilization, you have an issue before I even walk in the door. Okay? So what's happening here, though, is I want you to understand we thought about this. And so what we've done is we've built mechanisms into the management plane that say, unlike a traditional physical firewall. If I go build rules, and over time I just keep building rules and keep building rules, what happens to that rule list over 10 years? It gets ridiculously long. And how many of you have application owners who call you after an application is done and say, hey, we're done with the application, you can delete the rule? Never happened in the history of firewall management, okay? So you end up with a lot of rules. And if the rule that you're processing to allow the traffic is rule number 9,999, you're going to feel it. Because it took that time to get there. So we wanted to avoid that. So we actually have built into the management plane something called an applied to field that allows you to say this rule is applied to this workload or these workloads. So now if you're a workload that is irrelevant, you don't process that rule. So we're giving you the mechanisms to make this work as efficiently as possible while still giving you the best security that you can. I saw another hand over here.
So what makes it called VMware is you're supposed to be able to subscribe. And if you're running hot, you start dropping back. So there's almost a you have a one-to-one.
What do you mean it's
Well, it's there to run hot. And we have like DRA can get all the same fun for DRS isn't moving, and now all of a sudden we're dropping packets.
okay?
With the amount of traffic.
Because you're running at such a high CPU utilization?
Yeah, we're supposed to be a little oversubscribed.
There's oversubscribing and there's running to the point where you're dropping packets. There's a difference. You can oversubscribe because of that? Yeah, but at what point are you talking about oversubscription? You're not dropping packets in.
We're not.
Well, so then your CPU utilization is extremely high. Yeah. So, I mean, you would need more hosts then at that point. Like I said, if you're running, yeah. But if you're already dropping packets before you introduce security, you have a problem before this even exists. I mean, there's no way around that, right? You just admitted you're dropping packets because you're running hot. Well, I'm not even talking about NSX. That's networking.
Before we had the DFW.
Okay, so you're saying the DFW pushed their CPU utilization to a point that you were dropping packets? That's a unique case. You have to figure out what that is. Because I've never seen that before. What's that? Yeah, we can talk about it. We can talk about
I'm a telecom, so yes.
Okay, no, I'm not saying you're not, I'm just saying it's a unique case, right? So, all right, so why do we implement security in the first place? Is risk mitigation. So, if you are attacked, if something happens, there are three things that generally occur. One is a ransom. So do we pay the ransom, do we not pay the ransom? Could be a financial impact, may not be a financial impact. If you have all of the things in place to be able to recover from immutable backups and not pay the ransom, well then it's not a financial impact. The other one is brand, the impact to the brand. Now, realistically, this one's hard to quantify, but realistically, this one's probably the least of your worries, because as humans, we are becoming numb to this idea of our data being hacked anyway. I'm sure everybody in here has received some kind of letter that said, hey, there was a breach, your data was compromised, we're going to give you 90 days of credit protection or whatever it might be, and you're like, and you throw it out. No big deal. But the most important one for organizations is now this one. Class action lawsuits. So the lawyers are now seeing these attacks as payday. The lawyers are suing companies, and in many cases, the verbiage they're using is negligent cybersecurity practices. The lawyers are going after the corporations that are not protecting data. So Tampa General Hospital, near me down in Florida, was attacked. They were sued by Morgan & Morgan, the largest personal injury law firm. I don't think anybody was personally injured in this, but again, it's a payday. So Tampa General had to pay $6 million. MGM, I don't know if you guys followed the MGM attack, but MGM a few years ago, right after Explore, there was a big attack. MGM was sued, class action lawsuit. It just settled not long ago, $75 million is what they had to pay. By the way, my data was breached in that because I got a letter. I got a letter saying, hey, your data was breached. And there was 3 levels of breach. Mine was a level 3 breach based on the information. You know how much money they offered me? $18.41. Out of 75 million. Who do you think got the bulk of that money? The law firm did. That's why they're doing it. Now, word on the street is the ransom was 50 million. The lawyers are worse than the malicious threat actors. So we have to figure out as an industry, what is it I have to put in place so that I am not negligent in my cybersecurity practices? What are the things that I need to do so that if I am attacked, and we can't prevent everything because there's zero-day attacks, there's humans involved, it's never going to be 100%. But what are the things that I can do to prevent a law firm from coming after me in the event there is a data breach, right? What is the minimum that I have to do? And so that's what we have to figure out. So if we now look at it from the standpoint of risk versus complexity. So here we go. I'm going to do this and I'm going to start showing you guys some demos. We've got quadrants A, B, C, and D. At the top here, we've got high risk. At the bottom, we've got low risk. Over here, we've got low complexity. And over here, we have high complexity. And when I say complexity, what I'm talking about is how easy or how difficult is it to mitigate the risk. So I do this exercise with a lot of customers, right? And I tell the customer, I said, now think about your environment. Think about where you would put applications and services within these 4 quadrants. So they start filling stuff out. Oh, I got these apps over here and these apps here, and based on their risk profile, et cetera, et cetera, et cetera. Now, if you look at these 4 quadrants, A, B, C, and D, if you were starting your security journey, right? You got nothing, you know you need to protect, and now you need to start your security journey. How many of you would start in quadrant A? Go ahead. Quadrant A is high risk, low complexity. 1, 2, couple of you. How many of you would start in quadrant B? High risk, high complexity. Couple of you. A few more raise your hand. Quadrant C? And D? All right, it's definitely not D. Because D would mean it's very difficult to do and you get very little benefit from it. It's not C, because even though C is easy, again, you're not getting anything from it. There's low risk. You're protecting things that aren't even high value targets to an attacker anyway. So you're spending time doing something without much return on that. Now, most people think B. And that's VMware's fault. Because for years, all we ever wanted to talk about from a security standpoint was microsegmentation. How many of you heard that term? Microsegmentation. That's what B is. B is find those high value, money maker applications and protect those. But here's the problem with that. You may not know how that application is supposed to communicate. You may not understand the flows of that application. So I can't tell you the number of customers that I myself went out and talked to about microsegmentation. The customers nodding their head violently, yes, yes. And then I leave and they're like, I don't know. What happened? I don't understand. It seemed like it was such a good idea. They seemed like they wanted to do it. And then it turns out the customer says, well, I don't know how these things communicate. How would I build the rules? I don't know how A talks to B and B talks to C. I don't know any of that stuff. And so what did we do at VMware? We went out and we built a product called Security Intelligence, or NSX Intelligence back in the day. And we said, okay, here's what we do. We got a tool, and the tool will watch your application for 30 days, and at the end of 30 days, it'll give you recommendations. And even better, it'll take those recommendations, and with a push of a button, you can convert them into enforceable rules. Customers nod their head violently, yes, yes. You leaving? Hell no. Why not? Why didn't they do it? Because it wasn't a technology problem, it was a people problem. Think about it. For you people sitting in the audience, if you look at a list of flows and you can push a button and convert them into rules, but you have no idea if those things are right, you want to push that button? Probably not. It's an accountability thing. Do you want to take accountability for the way this application is supposed to communicate when you're not the one that owns this application? That's a very tough pill to swallow for somebody. Any of you ever push the button to do a vSphere upgrade? You know that feeling you get in your stomach? Right? Dear God, I haven't talked to you in a while, but please let this work right. That's the same feeling you get every time you have to publish a firewall rule. And you do those a lot more often than you would do a vSphere upgrade. Now, little disclaimer here, the default firewall rule for vDefend is any allowed, because we don't want everything just shutting off upon first deployment. So you really have to go in and block the things that you don't want, unless you're building a greenfield environment where you can turn the rule to deny, and then whitelist everything you want. So by default, everything's not just going to come crashing down with that, okay? But still, the same principle applies. If you're not the one that owns the app and you're not comfortable, you really don't want to be the one to push that button. So quadrant A is really the best place to start. Now, what's in quadrant A? Quadrant A is where you have to think differently about security. Because in most cases, what VMware would say, like microsegmentation, is, oh, find the important apps, find the important things. But A says, let's flip the script. Let's think about the way that an attacker wants to move through an environment. Let's reverse engineer the anatomy of an attack to figure out what it is that an attacker wants to do, and let's see if we can stop those things. So, in the anatomy of an attack, an attacker gets in. Could be phishing, could be social engineering, whatever it is, they get into a particular system. Now the chances that an attacker lands exactly on the system that has the relevant data that they're trying to steal is probably pretty slim. So they get into a random system, what do they want to do? They want to move, right? I want to get from this system to this next system to this. Now, tools have gotten very good to the point where they don't have to take too many hops to get where they want to go, but they still want to move. So we get in, we land on a system. We move to another one, we do command and control. We move to do another one, command and control. We move to another, command and control. Well, what is the #1 protocol used by attackers to move from one system to the next? Any ideas? From the guys that have seen this 10 times? RDP, Remote Desktop Protocol. Or ransomware distribution protocol, however you want to look at it. RDP because we allow it. RDP because we got a lot of Windows systems, because we use it. Now, I'm not talking about the open internal services client, right? It's RDP hijacking. They use the protocol to get in, they establish command and control, and then they continue to do this. So RDP is #1. We can also throw in there SSH is very common. SMB version 1 is also very common. Version 1 is old. It's very vulnerable. You probably don't use it legitimately in your environment, so closing it off could be very good. So if you just look at those three things that attackers want to use, if I can just close off those three things, I am mitigating the ability of an attacker to move laterally using the most common things. So again, this is not a situation where I have to stop everything. But let's say an attacker gets in, and then they open up their Hacking 101 handbook, and it says, move laterally using RDP, and they can't do it. Step 2 says, try SSH, can't do it. Step 3 says, use SMB1, they can't do it. If you're an attacker, time is money. So if the things that you normally do aren't working, what do you think an attacker does? They will find somebody else, right? Unless it's a nation state, or somebody hell-bent on attacking this very company, they're probably going to move on, because they want to get paid. So rather than trying to figure out new methods, they'll just find somebody else to send an email that somebody will click on for phishing. All right, let's say an attacker gets in, they move laterally, they find data that they want, and they want to steal it. They want to exfiltrate that data. What's the most common protocol used by attackers to exfiltrate data out of an environment? HTTP. HTTP? Somebody said? DNS. Is DNS. Yeah, name resolution. It's crazy, right? You're like, how? Why would they use DNS? Well, think about it. There's a physical firewall. In most cases, physical firewalls are probably set up to prevent FTP. And if you're a firewall admin and you're allowing FTP, but watching it or getting an alert, you're like, oh, that's FTP traffic, we don't like that, what's going on? But if you're a firewall admin and you're just seeing a bunch of DNS traffic, you're like, oh, people are doing name resolution today. Right? They're hiding within those protocols that are very common for our infrastructure. So between RDP, SSH, SMBV1, and DNS, those 4 protocols, if I can protect against the malicious use of those 4 things, I am mitigating the top things that an attacker wants to do. Now, we started this conversation by saying we need to make sure that we are not significantly impacting the operational model. So if I came to you and said, hey, you can block these 4 things, it's only going to take several hundred man hours and a few new staff. You'd be like, I can't really do that. But what if you could do all of those things in under an hour? And these are not things that you have to constantly revisit, constantly touch. These are static firewall rules that say once I put them in place, they're in place. Now, if you think about it, RDP should be very predictable. DNS should be very predictable. SSH should be predictable. These are not things that are changing over time. We know how they should be used. So we can build rules, right? If we start with RDP, we can build a rule that says if the source is any, and the destination is a set of jump boxes. You guys all understand the concept of the jump box, right? And we're talking about RDP, we'll allow it. If the source is jump boxes, and it's going to any, and it's RDP, we'll allow it. But if it's any to any RDP, we're going to block it. Now, why did I need that 3rd rule to block it? What did I tell you about the default rule?
Any.
Yeah, the default rule is allowed. Now, if your default rule was set to block, I wouldn't need that rule. But in brownfield environments, setting that default rule to block isn't an option. Okay? So I'm looking for ways to configure rules that will allow what I want and then block the rest of that utilization. So that's all it takes, 3 rules. If we look at DNS, if it's any, going to my internal DNS, and it's DNS, UDP 453, I'll allow it. If it's my internal DNS, going to my external DNS, and it's DNS, I'll allow it. But any DNS, I'll block it. 6 rules. Now, if you think, let's apply these rules. An attacker gets into an environment. Phishing, social engineering, whatever it is, and now wants to move laterally using RDP hijacking. First rule, is it an any? Yes. Are they going to the jump box? Nope, they're trying to hit some other random system, so it doesn't meet that rule. Is it a jump box? Nope. Is it an any? Yes. Are you trying to go to an any? Yes. Is it RDP? Yes, it's blocked. Can't do it. Let's say an attacker just so happens to land on the exact system where they want to exfiltrate data via DNS. Is it an any? Yes. Is it going to an internal DNS? Nope. They're trying to get it from internal system directly to an external system using DNS. So it doesn't meet that rule. Next one. Is it internal DNS? Nope. Is it an any? Yes. Is it going to an any? Yes. Is it DNS? Yes, it's blocked. It's very predictable. So we should be able to build these pretty quickly. All right, so let me transition and I'll show you exactly how these things get built. So you can see for yourself what the interface looks like and what the manageability looks like. Let me stop mirroring. There we go. And let's go here. All right. So this is the management interface for building firewall policy. I don't know why it's cut off there, but I'm going to build a tag. So when I talk about manageability, the ability to create tags, and these are separate from vSphere tags, gives me the ability to scale the firewall rules that I built, the policies that I built. So just creating a tag called jump hosts. I'm going to go find my jump hosts, and I'm going to apply that tag. Now, if you want to manually just add these to a group, you can manually add them to a group. But if you feel like, hey, in the future, I might add another jump host here or there, well, now all you have to do is tag it. It's a dynamic grouping mechanism where we're using tag as the deterministic factor for whether or not you are part of the group. So the scope that you see there is a logical organization of tags. So if you have tags that are all reflective of similar types of objects, then you could put them in the same scope. Now we'll go to the firewall policy. So here's where we build policy. I'm going to do these under infrastructure. So you can see there at the top, there's several categories. Those are just logical categories for the way we build policy. This one's called RDP policy, and now we'll add our rules. The first rule is going to be one of our allow rules. So from an any, now we'll go find our group. Oh, actually, it's going to create the group. So it'll show you how to build it. So we'll create a group called jump host, and then you'll see me actually define the criteria for the group. So you see add criteria, we'll put that there, and then put virtual machine tag equals, and now we'll use that tag that we just built. So any future jump host that you build, if you just tag them as jump hosts, they automatically get put in this group, and they automatically pick up all of the relevant policy. So back to the question about manageability, this is how we make things easier to manage. You can take this and you could grow it into production versus test dev versus DMZ. You can tag all of the things in those environments and build simple rules, and now we're not building per workload rules relative to one another. So here's my jump host group, and now you'll see the rule come to form here. So any to jump host, I'm going to now find my service, and these are all predefined in here. So all I have to do is search for RDP. There it is. And I got my first rule built. Set to allow. Now build another rule. So this whole video, by the way, with the creation of the groups and everything, is about 5 minutes. So 5 minutes to block the #1 protocol used by attackers to move laterally. Now this is allowing our jump hosts. So I'm going to go back and find our jump host group. And now we're going to go jump host to any. And again, we need RDP in there. Let me keep my name. Now, neat little trick here. I can grab RDP. Drag it down, and that one's going to be allow. So all I need now is that final policy, because the default policy is set to allow. So now I just need to build that policy that blocks everything. Notice it had to be dragged to the bottom because firewall rules are processed from the left to the right, top down. As soon as it hits a rule that matches, it's done. So if I left that block rule up at the top, that would have always applied. It would have been broken. And so the rules have to be applied in an order where the most specific rules go to the top. And so there's my block. I can publish, and now it's done. So very simple rule, or set of rules. Now let me switch, and I'll show you DNS. All right, so we're going to go back to tags. You can see a little more clearly here. We're going to go back to the tags, and you'll see me create a tag again. So this is no different than we had before. This is our internal DNS servers. And again, we can put a scope in here. And I'm going to show you a video here in a moment as to why this scope can be extremely relevant. And now I'm going to pick out my internal DNS servers, the ones that are going to get this tag. Again, if you want to manually add them to a group, you can. But I like the dynamic tagging mechanism. By the way, it's not just tags. If you've got a really good naming taxonomy, you can use virtual machine name. Name contains, name equals, whatever. Okay? So a lot of flexibility there. I like to think there's as much an art as it is a science to build these firewall policies in a way that makes them not only effective, but very efficient, while minimizing the number of rules that we have to build. So there's our criteria. So internal DNS is now set. We can just check it real quick, see the members. Right? Remember, I just assigned a tag. I didn't assign the members, but we can see it's pulling the members based on the tag. Now we have external DNS, and for these I can't tag, right? I can't tag external DNS entities, so I'm just going to use IP address here, and I'll manually put in an IP. So where is this relevant? Well, what if I've got physical hosts that I want to use IP addresses of because I can't apply a VMware-based tag to the physical host? We can still be able to reference those types of systems in there. So now we got internal DNS and external DNS, and we will go build our firewall policy now. So again, I'm doing this under infrastructure. To me, infrastructure is used for those non-negotiable type rules. These are things that are going to be relevant throughout the entire IT environment. So we're going to go find our DNS services here. And there's a slew of them, so I just choose them all. So nicely, you don't even have to define the ports and protocol itself. You're just referencing the service and it knows. This is the third rule we're building here. It's in a little different order. I can also log it. Keep track of it. And now we have to add the other two rules into the mix. Let's speed it up a little bit. So that's internal to external DNS. See the rule here. There we go. Internal to external. Now notice I'm just showing you an example here of the apply to. So this is where we take rules and we say, well, look, if it's only relevant to the DNS servers themselves, then why would I want this rule to be inspected by every other workload that's in the enterprise? This is relevant to internal to external. That's it. So I put the apply to. That's one less rule that's now being inspected by anything that's not a DNS server. And then here's the final rule. For any internal. There it is. Do you have a question? Yeah. Right. So if it's not in a federated type of environment where there's a global manager and you want to get these rules over, then yeah.
Can you repeat the question?
Oh, the question was exporting these rules, right? Instead of doing it via API, is there an easy button out of here to just export all of these rules? So there is backup that you can do for the rules, but not just a simple echo button. All right, let me show you this last video. So let's say that you build out these rules, these infrastructure rules. Let's say that at a high level, all you want to do is limit the blast radius in the event that something happens in your infrastructure. So you build environments of production, test dev, and DMZ. You tag everything in each one of those environments, and you build rules that says if it's the source of DMZ and it's going to production, we block it. If it's the source of test dev, we block it. So all that's done. You feel good about it. But now every new workload that you deploy, somehow you have to figure out how to get the appropriate tag onto that workload, which means now every time somebody wants a workload, it's going to have a ticket that says, hey, it's got to be in this environment, et cetera, et cetera. So when you start to tie in the tagging taxonomy that you build with the capabilities of automation, that's when you can create something like this. And this is where the scope comes into play. So this is an integration between the vDefend configuration and ARIA. So I'm not going to show you all the vDefend stuff because I just showed you the tags. But this is ARIA automation. So think of building a self-service portal that your users can come into. And they click on this object called security tags. That's just what I named it. And when that opens, it brings them to this page where they can then say, this is what I'm looking for. I need this number of VMs. This is the name of my project. But notice where it says environment zone. Everybody see that? So what's happened here is ARIA automation has been configured to go out to vDefend and pull in all the tags with a scope of environment. So when I build production test DMZ, the different tags, they all share the same scope of environment. So now the user has to choose, well, which one of these environments are you deploying into? Production test or DMZ. Now, if they pick production, well, now a second one opens up that says, well, what application security zone are you in? Why? Because in the architecture I defined, if you choose production, you also have to determine if you're part of open apps or secure apps. Again, I'm not micro-segmenting. All I'm trying to do is limit the blast radius between the things that I think are just unprotected apps don't care versus the apps that I really want to protect. And so now I'm giving the end user the ability to select this so that I don't have to be contacted every time a new workload is getting deployed. And by the way, let's say they choose production and open apps and like, oh, wait a minute, I messed up. They go back and delete it through ARIA. They don't have to call somebody to say, hey, can you go change the tag? They just delete it and they can rebuild a new one. Okay, now this is just one example, but you can start to think about all the things that you can integrate into automation. I could have users make requests for custom firewall rules. I could have users that determine, do I want IDS IPS on this with a checkbox, and then it's part of being protected by IDS IPS. So taking the security that you build and tying it into your automation, your orchestration, and again, this is ARIA, but it could be Terraform, it could be your own scripts, whatever it is. You then have the ability to protect things without having to touch them every single time they get deployed. And because of the architecture, once it powers on, it's already protected because it's built into the hypervisor at that point. All right, so with that, I think I'm running out of time. Let me ask, are there any final questions? Oh, I have 15 minutes? Oh, all right. Are there questions? I thought you said I had till 10:30. I got extra time. Cool. Questions? No? Okay, then let's talk about IDS IPS. So everything that we just talked about with firewall, right, runs in the hypervisor. The vDefend Advanced Threat Prevention, or ATP, gives you the ability to extend that security functionality beyond just the firewall piece. I'm taking it down. You're not leaving. You're all out. But let me just finish that point. So ATP adds the ability to do IDS IPS. I would not suggest this is something you carte blanche turn on for everything. I think this is something where you find the workloads where you want to protect against those known bad signatures, right? And you do that there. But beyond IDS IPS, there's network detection and response, which is the ability to correlate traffic to determine if there's a known attack pattern that's going on, right? Command and control, lateral movement, command and control, lateral movement, exfiltration, ransomware, all those things that map to the MITRE ATT&CK framework. The ability to identify malware, the ability to analyze your network traffic to determine anomalies. So we have an understanding of all of this traffic that's happening, and all of a sudden, two virtual machines start talking to each other that had never talked to each other before. That's an event you might want to know about. So that network traffic analysis is part of ATP. So when you look at security, security is not an all or nothing proposition. This is not something where on day one, everything has, you have to figure out what are the iterative steps I want to take and how far do I want to take it. So I've seen customers that stop at just infrastructure rules and IDS IPS, that's it. I've seen customers that want to go all the way through into microsegmentation. You get to pick and choose. None of these are predicated on the other. It's whichever one is going to mitigate the most risk for the least amount of time you have to invest in putting it in place. So with that, thanks for my extra 3 minutes, Brad, instead of 15 minutes.
You know, a little bit of OT here for Mr. McCain.